Hey everyone, welcome to Top Early. In this short video, we are going to learn about voltage division rule and how it is derived. So let's start our lecture. When multiple elements are connected in series in a circuit, we use voltage division rule to find voltage across each individual element. First, we will learn the rule using this simple circuit having two elements in series, and later we will generalize the rule for circuits having multiple elements in series. These elements can be resistors, capacitors or inductors. I am not specifying anything in particular. So let me just use Z1 and Z2 to specify the impedances of the elements. Now we know that in a series circuit, the current through all the elements in the circuit are same, but the voltage across elements depend upon their impedances. The current through the circuit can be found using Ohm's law. Therefore, current I through the circuit is equal to supply voltage V by Z1 plus Z2, right? Let us name it as equation number 1. Now again using Ohm's law, let's find the voltage across the element Z1. Therefore, V1 is equal to current through Z1, which is I, into Z1. Also from equation 1 we know that I is equal to V by Z1 plus Z2. So substituting that over here, we have V by Z1 plus Z2 into Z1. So this is the voltage division equation for voltage across element Z1. Similarly, voltage across element Z2 can be found as V2 is equal to V by Z1 plus Z2 into Z2. An important thing to note here is that this V is the supply voltage V of the circuit. Okay. So this is how voltage division rule comes into the picture. Now if Z1 and Z2 are purely resistive, that is Z1 is equal to R1 and Z2 is equal to R2, then using this equation we have V1 is equal to V by R1 plus R2, because Z1 is equal to R1 and Z2 is equal to R2, into R1. Similarly, V2 is equal to V by R1 plus R2 into R2. So this is the voltage division rule for elements that are purely resistive. Now if Z1 and Z2 are purely inductive, then we learned in network theory that Z1 is equal to j omega L1, where omega is the frequency of operation, and Z2 is equal to j omega L2. Now the voltage across L1, V1, can be found out using this equation, which is V by Z1, which is j omega L1, plus Z2, which is j omega L2, into Z1, which is j omega L1, and cancelling out these j omegas, we have V1 is equal to V by L1 plus L2 into L1, and V2 is equal to V by L1 plus L2 into L2. Lastly, for the capacitive case, that is when Z1 and Z2 are purely capacitive, then Z1 is equal to 1 by j omega C1 and Z2 is equal to 1 by j omega C2. Substituting the value of Z1 and Z2 into this equation, we have V1 is equal to V by 1 by j omega C1 plus 1 by j omega C2 into 1 by j omega C1. Taking out 1 by j omega C1 on both numerator and denominator, we have 1 by j omega into V by C1 by 1 by j omega into 1 by C1 plus 1 by C2, and these cancel out, and finally we have V1 equal to V by C1 plus C2 into C2, and similarly for V2 we have V by C1 plus C2 into C1. Please take special note of this, because in the capacitive case, when we need to find the voltage across C2, we are multiplying the numerator with the value of capacitor C1 and vice versa. Now let us generalize this concept of voltage division rule. Consider a series circuit having n elements in series and their impedances are Z1, Z2, Z3, etc. to Zn. In this case also, just like we learned, the current I is given by V by Z1 plus Z2 plus etc. plus Zn, and the voltage across the kth element is given by Vk equal to V by Z1 plus Z2 plus etc. plus Zn into Zk, where k is equal to 1, 2, 3, etc. to n. So this is the generalized voltage division rule for finding voltage across any element in a series circuit. Now before ending the lecture, let me give you a small homework. I want you to find the expression for voltage division if all the impedances are purely resistive, if all the impedances are purely inductive, and if all the impedances are purely capacitive in a series circuit. To find the answer for this, just proceed like how we did for the circuit with two elements. And once you get the answers, type them in the comments so that it will be helpful for others also. I hope that all the concepts that were taught in this video are clear to all of you. If you have any doubts, please feel free to ask them in the comments. Either we or some other viewer will surely help you. If you found this lecture useful, please like the video and also support us by subscribing to the channel. Thank you for watching Topperly and have a nice day.